everybody. Thanks for joining us. This is Steve Taylor, and I'm here to introduce Arvind, and he's going to be talking about data science and the Ortelius platform. Welcome, Arvind.
Hi, Steve. Hello, everyone. I am Arvind Singharpuria. I am a college student from India, and I am in my currently second year of my college life, and I am doing my BTech degree in computer science. Today, I am exploring the topic of how we use data science in the Ortelius open source project. Ortelius is a Microsoft catalog that version and track microservice. Means it take all of your microservices. It gives is the version, and each iteration or in each chain of these microservices, it gives it a different version or the updated version, and in this way, it tracks and manages your microservices for your application. It is also a incubating project under the government of CD Foundation. Thank you, Steve, the CTO of Australia, for giving me such an opportunity to share my screen and share my views on this topic.
You're welcome. Welcome aboard. We're glad you're able to take up this topic and give us some insight into what we can do with machine learning and the data we have in Ortelius.
First, let us try to understand what is bill of material report and the blast radius report. In the first diagram, the orange boxes are all the different microservices. Take it as a part of the program or part of the application that you are using. It may be any front end, it may be any back end, it may be a database part. And in the pink boxes, they are the actual applications that are using all these type of microservices. So for example, if this is a full stack application, then it may be the front end part. The second one may be the back end part, or maybe the its front end part has many different microservices application. So the bill of material report shows us the connectivity of how an application is connected or sharing is showing the relationship between an application and its microservice part. And in the right side, the same it is a blast radius report. It is little bit slightly different, but not that much. But in this diagram, the orange one is the same, the microservices part, and the pink one is the same application that we use. And this diagram is showing that a single microservices is used by three different programs. It is only showing the microservice, but we can't tell anything about its version. But we will discuss it later.
About the difference report, what is that showing us?
It is showing a straight relationship between our microservices and application and how we will use that. For example, the orange one is our microservice. The pink one, which is connected, which is using the microservices, is a application, and the hipster store cluster, which is the dark blue one. It is a type of cluster that is using types of hipster store or many hipster stores. Maybe it has three different programs for the production, for the staging, and for the testing environment. And the last one is the local host where we are showing our end result. Now let's talk about the main data points that we want to cover in this presentation. The first one is license consumed by a component version or microservices. It's basically tell about the license or it is telling about the version of the microservices that we are using. Like every microservice has an updated version, it has many versions, and it has many dependencies. This license covers all the data about its dependencies, how it is changing, and what is the iteration that we are doing in each version of that component or that microservices. The second one is the common vulnerabilities and explorer or CVEs found in the component version. CVEs was first introduced by Mitre company to detect the problem that we are using or they are facing in their application. They then started making a report writing of CVEs, and but in the later era it is difficult because every company has their own CVEs. So they or pro, they started giving them a tag or like an ID, the global ID from which we are categorized the CVEs. It's contained the three parts. The first part is the identifier. The second part is the problem is this statement. It is happening, and in the last part it contains some references related to this problem. Our third part is service to service mapping. In this section, we are talking about REST API endpoint exposures and REST API calls. Basically, it is showing it is telling us about the REST API that we are using and what are the results it is showing at different conditions. And last one, we are talking about trust score. Can trust a microservice. It is like a score that we are going to make or we are going to predict about the microservices that we are using. And on the basis of that score, we are getting that does we are using the right component or we are using the right microservice for our data. We are data hoarders. Basically, we are the producer. We are the producers. We are looking to grab data from the low level, example npm packages, Python module, operating system packages, and association to microservice further. We are doing it to take changes over time, and basically to mean take changes, it means we are iterating, we are keep recording of our version of our microservices. We are keep recording of the changes we are doing in our application so that in future if we want to go to or roll back to the previous version or we are using a specific component that we are depreciated or that we are not used so much, then we can easily move on and keep track and we can easily find out that one on the basis of these changes. The low level data is then rolled up on the application level. This sometimes creates risk, and for risks I mean the dependency changes. We have to manage all the dependency that we are using. For example, I have an application A. We is just using two dependency, two different softwares, V1 and V2. And in the current version, I am using the updated version of V1. But if I roll back or if I go back to the previous version, maybe it is working on the not the updated, it's maybe working on the lesser version of my dependency. Then it creates risk because we are moving our entire base to that part. So we have to keep track of that version, and it creates risk to using that microservice at that point. And by using this, we are scoring the application version with a disk score that on the basis of which version we are using that it is less that is it says less risk score as compared to its previous version or is compared to its updated or the previous versions. Now is the main part of our presentation, using the data for machine learning. For example, GitHub has stars. People give the star to any product, but the main question is how can Ortelius give stars for a disk value or favorites? For that, we need some arguments or we need some type of data about how we can do that, on what basis we can give stars to values or favorites. So for assessing the risk of a microservice, these are some of the points. First one, Had a microservice been deployed successfully and consistently? If we can deploy our microservice easily without any problem, that definitely it has a low risk value because we are not it is not getting that much problem and it is works fine on the deployment. Second point, how many application does the microservice impact? If its value is over 10, it has high risk value. What does it mean? That if my application is using more microservices, then we have to keep track of its dependencies of that number of microservices. And for this, we have to keep tracking of that part. For example, if you have over 10 microservices, we have to keep updating or we have to keep managing its updated version or its latest version of 10 parts. So it is creating much more it is making much more complexity as compared to one or two microservices. So it definitely has a high risk value. What domain is in? For example, if I am facing any problem in the front end part, then it is a little less high value. If I am facing the problem in the database part, is maybe it is slightly high value at this point. But if I am facing the problem in the security part, then it is seriously a major concern. It will affect my whole application, and maybe my application also shut down due to this. So we have to keep tracking of these type of changes. Next, end user would assign a risk value to their domain. The user that are using our application has different experience than us because we are the producer and he is the consumer. So there is also an option so that he can assign risk value to the application. He can tell us about the experience that he is facing in our application. Number of CVEs. Definitely, our application has greater number of CVEs, then it has a high risk value. License exposure. Are we consuming a license that is not true? We should use the light license of microservice. We should not use any spam. If we are using it, then we are not providing any guarantee that we are genuine or we are using the right thing. Trustworthiness score with by trusted partner. It is also the work of end user. End user is will give us the trustworthiness score. How much trust he can give us to our application or how trustable our application is. Only customer can tell us about this. And the last one is leave here for dependencies. First, let me tell you what is leave here. If suppose I have a microservices A and currently suppose it is December and currently it is using a version 5.0, but in the next December, in maybe December 2022, the same application we are using is version 5.1.12. So its leave year distance is 1 year because we are the is the main gap of the two versions that we are using. So its leave year is directly 1 year. And suppose we are in another, let's take another example. Suppose I have a application A. It has two microservices. One has leave year 3 years and and the second one has a leave year of 4 years. Then our total leave year is 3 plus 4 equal to 7 years. And if our application has leave year more than 10 years, then it has high risk value. We are doing it keep back. We are using the less stable version as compared to the current one. Now let's talk about the dependency relationship. How does one microservice affect another microservice or application? For this, let's take the example of the previous blast report one. Yeah, in the blast radius report. In this example, I told you that this is the three application that is using the same microservice. But I also told you that it maybe a different version that I will talk to you in later. And suppose HipStore is using version 1.0 of car services, and HipStore Laver is using version 2.0 of the car services. They both are using the same microservices, but both are using the different version. And so we have to keep tracking of each version. Maybe they are using the same functionality, or maybe they are using different functionality. If you are using same, then is it of no value that we are giving is two different version. We are using two different version. For this, it create problem, and the problem, I mean, it is hard for us to keep track of this. We are using the same thing, but for different user, different version, and it is used by the same functionality in different applications. So it is the version part of the blast radius report that I want to discuss with.
When we start assigning all of these risk values to the different microservices, what does that allow us to do for our end users?
Our end user can trust our application more. Like they are using the microservices, but no one guarantees you that it is the best or it does not create any problem, because we are using a vast amount of our application is so big. And so this microservices part, this this score will give them more assurance. And second part, like we are making so many changes in our application, but how can we assure that the changes we are doing is good enough, or is it not bad for our application? So by using this analysis, it gives every changes a risk value score, and for this risk value score, we can easily assess that the change we are making in our application, that it is good or we should not make this type of changes. Using the data for machine learning. In this example, we will talk about why we need a risk score. I talked about it in the previous slides a little bit, but yeah, let's explore it more. We, we will use a ML model to determine the risk score of the data we are taking or we are using. But why we need a ML model to score every changes made by the developer? Let's say we have 100 developers making two microservices updates a day, and we end up getting 200 changes per day that need a risk score calculated. But why do we need a risk score? So out of 200 changes, two changes can destroy our application. So we have to prepare before. That's why that this changes can affect our application or not. Because it is just true, for 100 changes we can bear up for, but what about we have a massive big company and we are putting thousands of changes per day? Then in this case, it is hard for us to determine that which path creates any problem. And we can't roll back thousands of changes into the previous funnel. It will take so much manpower and time. So for this, we need a criteria, or we provide them a risk score. So it decide that the changes that we are using is suitable for our application or not. And the next question is, yeah, let's we give the changes the risk code and what we do next. And this part is covered in the pipeline part. We can make in the CI/CD pipeline. Suppose uh, we make a change and it has very low risk code, maybe 0.1 or 0.2. Then we can skip the steps for low risk changes, and we can directly ship it to the production. So it will it will minimize some time that we will use to pass in the three stage, the depth and the stacking path. And suppose it's at a very high risk value, like 9 or 9.9, then we have to pass it through all the three steps, and maybe we need some additional testing, manual approval step to to make sure that it does not affect our application. Event driven pipeline make it easy to dynamically change based on the risk score. Event driven pipeline mean in the monolith part, instead of function, we trigger events to do the changes in our application. The next part is run different pipeline based on risk score. Definitely, we can set up maybe a single pipeline for the low risk value, two or three pipeline for the middle to high risk value, and for the highest risk value, we can add some additional testing, manual approval test, or a man can check these changes so it does not affect our application.
So do you think with the number of changes that happen in these larger applications that have a lot of microservices that you could do this manually, or is that even possible?
In case of large application, it's hard to do this manually. So we have to build a model, or we have to automate this stuff for us. So it can automatically provide the risk value to every changes. And based on this risk value, we will then filter it out, or we will categorize it into different categories on the basis of its risk score value.
And do you think the as we apply these models to the data, that the models will be able to start learning about the success or failure of the changes?
Yeah, definitely. Uh, when we make a model, and it will improve every time it track any changes, because every time it track any vulnerabilities or it track any failure, it add it into its data, and it is learn from it. So next time that type of error occurs, it will automatically tell us that it is not good, it will create problem. So in this way we are building a more secure or more powerful model to do that stuff.
So based on what you just told me, it sounds like when these models start learning, that the stability and the security of our applications is going to get better, and that we're going to have fewer failures around what we're releasing because of our ML model being able to learn. Is that correct?
Yeah. For example, let's take a simple example. I have a front-end application, and there are three people contributing to my application, and I am using maybe let's say a Vercel, which provide the automatic checking of the application. Let's take an example that I am the main contributor, and someone else did a PR, and it's create a problem in the application. It has lost, and if I have this score, and if the risk score is low, then I can easily merge that PI into my application. But if it has high risk score, I can definitely tell him to cancel that PR and make another PR, so that in this way I am it is safe. We are using we I don't have to iterate or roll back to the previous version of my application if by mistake I merge his PR into the production part.
Got it. This is going to really help with being able to get developers changes to production much faster in a safer way.
Yeah, definitely it will save time and it will help in the working in the safer way. The data we are missing, and it's what we need this type of data. We need this data for our application. The first one is the environmental or cluster configuration and security scope. Is we get it from the Kubescape. Trustworthiness of a package and module is for idea. We want some transaction logs from promisers and Kali. We need CV data for the different languages we are using like Golang, Java, operating system packages, Node.js. We need license data for the backend languages we are using like Golang, Node.js. We need service now or issue for a service. And we need the packet configuration, or simply say we need the different version, tracking version of the configuration that we are using in the each version of our microservices. If you want to learn more about these, then definitely check out these resources that I have mentioned in this section. You will definitely learn more about these topics like leaf years, CVE, why data is important in microservices, and blast radius report.
So thank you again, Arvind, for doing this. And like I said, if you're interested in more about data sciences and where we can take the information that we're grabbing from the different parts of the Ortelius project and what we can do with it, or if you have ideas about what we're missing, other ways we can view the world, please reach out to us or just reach out to Arvind on LinkedIn or Twitter. Thank you, Arvind.
Yeah, thank you, Steve, for giving me this opportunity and the stage.
Thanks.
Have a great day, everyone.